My name is Stephen Odhiambo, teacher of chemistry and maths. Today we want to learn chemistry, a Form 4 topic, extraction of metals. More specifically, extraction of lead metal. To start with, we'll start with saying that before the lead metal is extracted, we first mine the ores from the ground, that is the earth crust. As we have discussed earlier about extraction of metals. So to start with, I would start by saying lead metal ores include galena, which contains mainly lead sulfide as the main constituent in it. The next ore we have is cerussite, which is actually containing lead carbonate. And we also have anglesite, which contains lead sulfate. All these are ores. You may be wondering what I mean by ores. An ore is a rock rich in mineral, most especially a metal. The methods of extraction of metals, as we have discussed earlier, are two methods. There are two methods, namely reduction method and electrolytic method. Specifically for lead, extraction of lead metal, the method is the reduction method. Is the method used in the extraction of lead metal. Before the extraction process starts, the lead ore is concentrated, which simply means impurities are removed. That is removal of impurities. To the minimum. In the preparation of an ore, the following steps are involved. Steps are involved.
The first step would be that is using a magnet to attract any magnetic material. Use of magnets to remove magnetic materials after which that is the next step, that is step number 2, where we use suitable detergents, and water to wash the ore, to wash the ore, to wash the ore, to wash the ore. After which the ore is further concentrated by, that is step 3, a process known as froth flotation. Which entails, first thing done to the ore is that the ore is crushed. After the ore is crushed, number 2, it is mixed with oil, and water. Number 3, a blast of air is passed through the mixture, and a froth rich in the mineral floats on the surface. The froth is then skimmed off. The froth is then skimmed off from the surface. A continuation, we say the froth is then skimmed off the surface, ready for the extraction, of the metal. Now, just to recap on what I've just said, lead metal is manufactured or is extracted by reduction method. But we're seeing before the reduction method, there must be preparation done on the ore. And we've said in the preparation, first a magnet is used to attract any magnetic material on the ore. Number two, we have talked about it being mixed with oil and washed with detergent so as to remove some of the materials. Now, specifically to give the reasons of these steps, the first one was the ore being crushed. Why is the ore being crushed? The ore is crushed so as to increase the surface area of what? Concentration. Concentrating the ore. Concentrating the ore. Concentrating the ore. Then we have also talked about it being washed, and after being washed, mixed with oil. So water or washing with water. This helps remove the earthly materials. The earthly materials. Earthly materials such as soil, which sink at the bottom during washing. The bottom during washing. Number three, we have talked about mixing with oil detergents. What is the purpose of the oil? The oil here purposely to coat the ore and helps the concentrated ore float on water where it is skimmed off. Where it is skimmed off. Now, after the oil is skimmed off, and for this case, the main ore here from which the ore is normally extracted, the chief ore, that is galena. Is fast fed into a roasting chamber, where regulated amount of oxygen is supplied to convert it to an oxide, as illustrated in the equation below. So we are seeing after the concentration, the ore is taken to the roasting chamber. In the roasting chamber, the galena, which mainly is lead 2 sulfide, is converted to an oxide. And this is how it is converted to an oxide. We'll have the PBS solid plus oxygen forming lead oxide plus sulfur 4 oxide gas. To balance, we balance by putting a 3 there, a 2 here, a 2 there, and a 2 there. So this is the equation of the roasting of lead sulfide, that is galena, the main thing in galena, to form lead 2 oxide. After the roasting, the lead oxide plus coke and limestone are fed into a blast furnace. Fed into a blast furnace. Fed into the blast furnace. Now, in the blast furnace is where we have the reduction process, where the main method we talked about reducing the oxides in order to get the metal is done. So what happens there? We have fed coke into the furnace. Coke is carbon, and in the furnace it is a reducing agent. Together with carbon 2 oxide, which is formed as per the equation below. Equations below. So the carbon first combines with oxygen gas to form carbon 4 oxide gas, after which the carbon 4 oxide gas combines and is reduced by the remaining carbon, that is coke, to form carbon 2 oxide gas. Here, the carbon and the carbon 2 are the reducing agents, which reduce lead oxide to lead metal. As illustrated in the equations below. Now it is very clear here, we are saying after the oxide coke, that is carbon, and limestone are fed into the furnace. The first very important reaction that takes place is that there is formation of carbon-2. Even though coke, that is carbon, is already a reducing agent. So both the coke and the carbon-2 oxide formed reduce the lead oxide to lead metal. And this is how it occurs. Two possible reactions, that is PbO, that is the oxide, plus carbon, forming plus lead metal. But we can also have PbO solid plus carbon-2 oxide forming Pb solid, the metal, plus carbon-4 oxide gas. These two reactions are the reduction reactions. But directly we could also say that lead oxide could also just be reduced by carbon to lead metal, and the carbon forming carbon-4 oxide gas. But in doing this, we will be required to balance there by putting a 2 and balancing here by putting a 2. All these three equations are okay if you write them as the reduction equations for the formation of the metal. Now, during the roasting, not all of the sulfide could have been converted into lead oxide. So what happens? It is in this extraction of lead that another special reduction process is involved, and there is addition of iron metal, and the purpose of addition of iron metal, this is to reduce the unconverted, lead sulfide to lead metal. The reaction occurs in such a way that iron combines with the remaining unconverted lead sulfide to form iron 2 sulfide and lead metal. All in all, both of them are just but reduction processes. Now, in the blast furnace, three things were fed into the furnace. And one of the things that was fed into the furnace was the oxide, which we have discussed. The other thing that was fed into the furnace Apart from lead oxide, we also fed coke, which I've said is carbon. We have also discussed the fate of coke. The only other thing we have not discussed is limestone. Limestone is majorly calcium carbonate. What is the fate? What is the fate of limestone in the furnace? This is what happens to the limestone. So the calcium carbonate is decomposed to form calcium oxide and carbon dioxide gas. That is calcium carbonate, the equation, decomposing to form calcium oxide plus carbon
that area
gas. The fate of carbon dioxide gas is known. And the fate is that the carbon dioxide formed will be reduced by coke to carbon 2, which is one of the reducing agent. What about calcium oxide? Now the calcium oxide formed here purposely is purposely used to help remove the impurities in the lead oxide. The main impurity in galena is silicon dioxide. In other words, silica. So the calcium oxide formed after the decomposition of limestone. The calcium oxide formed after the decomposition of limestone reacts with the silicon dioxide to form calcium silicate. And it is this calcium silicate that is obtained from the furnace as a slag. So we say we have calcium oxide formed from the decomposition of limestone. This reacts with the silicon dioxide, silica, and what is formed is calcium silicate. Which forms part of slag. What is the fate of calcium silicate? Now there are two things here coming out as byproducts. One of them was a product one of them was iron 2 sulfide formed, and the other one is now calcium silicate. The two combine to form slag. So iron 2 sulfide and calcium silicate form the slag. Now the slag here is a bit lighter compared to molten lead. The lead collected in this method is collected in molten form, and so it will float in the blast furnace at the bottom. It will float on top of molten lead and separated from lead. Slag being less dense than molten lead, floats on the surface of molten lead and is separated. Now, after extraction, the lead obtained from here is not 100% pure, and we have said it is obtained in molten form. So what is done to make it pure? The purity, the percentage purity of the lead extracted by this method is increased by blowing. So the lead metal, we are saying, produced or obtained from the blast furnace contain impurities. And we are saying the impurities are removed by fast passing a blast of air into the molten lead. Into the molten lead. Since the impurities are less dense than molten lead, they are oxidized. On the surface of molten lead and are skimmed off. So we are seeing the lead metal obtained by this process contains impurities. The impurities are most likely to be carbon. How are the impurities removed from the molten lead? We are saying that the first thing that happens is that we blow air into the molten lead. And since the impurities are less dense than molten lead, they float on the surface of molten lead. So what happens? When the air is blown over the molten lead, they react with oxygen, they are oxidized, form oxides, and are skimmed off from the surface. And we obtain lead. But other than that, a more pure lead is obtained by purification through electrolysis. And by the way, one of the major and the best ways of purifying metals is electrolysis. So we are saying the lead metal can further be purified by electrolysis. In the electrolytic cell, of purification of lead, the following are used. The first one is the electrolyte. A solution containing lead 2 ions, most likely lead nitrate solution. The electrodes used, we have the anode made of the impure lead. The cathode made of pure lead metal. We can illustrate this on a diagram. And this is the diagram. Now, during the purification, the anode, which is made of impure lead, the pure part of the metal dissolves according to this equation, that is lead solid losing 2 electrons to form lead 2 ions. To form lead 2 ions. While at the cathode, lead 2 ions accept electrons, that is 2 electrons, to form lead metal. To form lead metal. To form lead metal. Now, that is exactly how lead metal is purified. And the cathode is always stripped off to remove the pure part of the metal formed, and lead is collected. Lead obtained is collected that way. Unless there is a question, unless there is something to discuss, I think that is all about extraction of lead. So just to recap and to summarize on what happens, we have said the chief of extraction of lead is galena. What is first done to the ore is that the ore is concentrated. Process of concentrating the ore, you have said one involves using a magnet, removing the magnetic materials from the ore, after which the ore is washed using suitable detergents and water, after which the ore is again mixed with oil and water in order to concentrate it. A process known as fourth flotation, which involves crushing the ore into fine powder so as to increase the surface area for concentration. The oil purposely meant to coat the ore and help it float on water, while the water is supposed to help sink the alkali materials as we concentrate the ore. After the ore is concentrated, we have also said that the ore is taken to a roasting chamber. And in the roasting chamber, the lead 2 sulfide is converted to lead oxide. After the lead oxide is formed, we have said that the lead oxide is reduced to lead metal using 2 reducing agents. And the reducing agent in this case are the coke, which is carbon, and the carbon 2 that is formed when carbon 4 is reduced by coke to carbon 2. We have also discussed that. So in the process of reduction, both carbon and carbon 2 oxide are the reducing agents, reducing the oxide to metal. The metal obtained from the furnace, we have said, is also not pure. It is purified by 1, passing a blast of air through the molten lead. And number 2, we have said it can be purified by electrolysis method. That's all for today. All the best. Next time we'll discuss properties of the metal, that is lead.